We're going to take a look at the last of the factoring methods that is covered in Algebra 1, known as completing the square. So previously we learned about factoring just straightforward trinomials that are easily factored into its two binomials, either via greatest common factor, grouping, the Xbox area model. We learned that method. We've also taken a look at the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, that is a formula. It works every single time, and it is available to you on the Common Core reference sheet whenever you take the exam. There is another method that is a little more thought involved and takes some time to get through. This is known as completing the square. So question becomes, what is it? What's it look like? And how do we use it? Well, first of all, we take a look at the standard quadratic equation, ax squared plus bx plus c equals 0. So this is the format that we like the equation to be in whenever we have to either factor or use the quadratic formula. The roots or zeros or solution, whatever they so desire to call it, those are the x values that make the equation equal 0. And again, some methods. How do we find the methods? Well, we got greatest common factor, we have grouping, we have difference of two perfect squares, we've got the Xbox, and now we have the quadratic formula. Now the first four, GCF, grouping, the difference of two perfect squares, and Xbox, they do not always work. It's only going to work if the equation is set up and you can take a quick look and know that it's going to work. The quadratic formula also works every single time. So given an option, going to the quadratic formula would probably be your best bet at figuring out what the answer to the equation would be. Now there is another procedure known as completing the square. It also, like the quadratic formula, works every single time. The difficult part with it is completing the square is a more difficult process, and you have to know how to do it yourself. It is not given to you on any reference sheet, and anytime on a New York State Regents exam, 9 times out of 10, they're going to ask you to solve the quadratic equation using the method of completing the square. So that's why I cover it. So in order to use completing the square, we have to make sure that we just start with x squared. If I have anything in front of that x that is not 1, I have to divide the entire equation by that number. So here we're given 2x squared minus 12x plus 14 equals 0. In order to use completing the square, I have to get rid of that 2. So we are going to divide everything by 2. And this includes the 0. So 2 divided by 2 goes away. We are left with x squared. Negative 12 divided by 2 will give me minus 6x. 14 divided by 2 gives me plus 7 equals 0. So far, nothing too strange. Now, here is where it gets a little more wonky. We need to actually rearrange the equation. So it's almost like we're solving for x. We need to get the variable on one side of the equal sign and the solid number on the other. So here we have x squared minus 6x plus 7 equals 0. We are going to keep the x's on the left-hand side here, and I'm going to move the 7. So here we're adding 7. So to move it, I have to subtract 7. So what that does is 7s will cancel, and we are left with x squared minus 6x. And here comes another strange bit. I am actually going to leave a little bit of space here and have equals -7. So once I have it set up, x squared minus 6x equals -7, here comes the funky part. The magic number that we're going to be dealing with here is 2. We're going to divide the second term by 2. So x squared is our first term, 6x is our second term. So second term is divided by 2. So when I divide -6 by 2, I get -3. Now what I'm going to do is I square it. So second term is divided by 2, then I square it. -3 squared gives me 9. Now what I will do is I have to add 9 to both sides of the equation. So here we have x squared minus 6x plus 9 equals -7 plus 9. Again, what I do to one side, I do to the other. I added 9 on the side with x squared minus 6x, so I have to add 9 to -7. What I have done is I have created what's known as a perfect square trinomial. So x squared minus 6x plus 9. 3 terms, it's a trinomial. It is known as a perfect square trinomial. What this means is I now have when I factor it, I will actually have a binomial squared equals whatever we have. So what is the binomial going to be? Well, it's going to be the letter in our problem. In this case, it's x. The symbol will be whatever's on our middle term, minus, and then it's going to be the square root. It's actually going to be what we found when we cut in half. So x, and then when we cut -6 in half by 2, we get -3. So we have x minus 3 squared equals, and then -7 plus 9 gives me 2. So here we have x minus 3 squared equals 2. What we'll do now, so we divided by 2 in step 1. We rearranged it to get the filler over here in step 2. Step 3, we halved, squared it, and added to both sides, which we did. We created an expression as a perfect square trinomial, x minus 3 squared. And now what we're going to do is we're going to solve for x. So x minus 3 squared. So here we have our equation, x minus 3 squared. I want to solve for x. So first thing, I need to get rid of this exponent of 2. So we're going to take the square root of both sides. What this does is the square root and square will cancel out, leaving me with whatever's underneath. In this case, it's x minus 3 equals, and now I have square root of 2. Anytime I take the square root of a number, we actually get 2 values. We get a positive and a negative value. So we have plus and minus the square root of 2. And last but not least, we want to get x by itself. So we're going to take this minus 3, and we have to move it on over. So we're going to do the opposite of whatever's going on here. So subtracting 3 in the problem means we're going to add 3 to both sides. So -3 plus 3 will cancel out, leaving me with x equals, and then here we have a whole number 3, and then an irrational number -2. The whole number will come first, 3 plus and minus the square root of 2. And that is our answer using completing the square. So yes, this is a pretty involved process. But again, there will be a question or two eventually that you are asked to use this method in order to figure out the values of x. So again, we have to have our problem as x squared. If I have a number on x squared, we must divide everything by that number. In this case, it was 2, and it worked out nicely because all my numbers were divisible by 2. And then we have to get the number by itself, and then the funky part, second term divided by 2, then squared, and whatever we get is added to both sides. We create this perfect square trinomial where it's the letter in our problem, x, and then whatever number we got when we divided by 2. So letter is x, we got -3 when we divided by 2, and it is a perfect square trinomial, so we are squaring, and that is equal to 2. And then we go through the process of solving for x. Take the square root of our numbers, add 3, and we get our answer. So here, let's take a look at some more problems. We must use completing the square, expressing each root in the simplest form. So x squared minus 2x equals 12. So first things first, we have to make sure that it's just x squared, which it is. So we're good with that. Second thing is once we do that, once we have x's to one side, number to the other, we have to take that middle term, divide by 2, and square it. So here we're in the correct format. We got x's on one side, number on the other of the equal sign. So we're going to take this middle term, -2, and we divide by 2. We'll get -1. And I have to square it. -1 squared gives me 1. Now what I'm going to do with this 1 is I am going to add it to both sides of the equal sign. So my new equation is now x squared minus 2x plus 1 is 12 plus 1. So here now we have what's known as a perfect square trinomial, meaning when I factor it, I am actually squaring a binomial. Now what is that binomial? Again, the letter is whatever letter we got in our problem, so x. X is the letter in our problem, so x. And then the number I'm going to put is the number we got when we cut in half, so -1. So this x squared minus 2x plus 1 is actually equal to x minus 1 squared. Equals, and then 12 plus 1 is 13. Now to solve for x, I have to get rid of this exponent of 2, so we'll take the square root of both sides. That's going to cancel out the exponent of 2, leaving me with x minus 1, gives me, and because I took the square root of a number, I actually get two values. I get a positive and a negative value of the square root of 13. And last but not least, I'm going to add 1 to both sides. The 1's will cancel out, leaving me with x equals, and then the solid number is always written first, 1 plus and minus the square root of 13. And that is our answer. We actually have two answers here, 1 plus the square root of 13 and 1 minus the square root of 13. Now number 2, we're given 2y squared plus 3y minus 5 equals 4. So in terms of setup, it doesn't look very nice. Again, whenever we use completing the square, we have to make sure our leading variable is by itself. So y squared is our leading variable, meaning it has to be just y squared. So first thing, I'm going to divide everything by 2. So 2 divided by 2 goes away. It leaves me with y squared. 3y divided by 2 is not very nice. It gives me a decimal, so I'm going to leave it as 3/2 y. And then negative 5 divided by 2, again, it doesn't come up nice, so I'll leave it as negative 5 over 2 equals, and then 4 divided by 2 gives me 2. So at this point, everything has been cut in half. And next thing, I have to make sure that y is by its lonesome on the one side. So here we have y squared plus 3y minus 5/2. I got to move the 5/2 over. I need to make sure it's on this side of the equal sign, it's just y squared plus 3/2 y. So I'm going to add 5 halves. So negative 5 halves plus 5 halves is going to cancel out. So we're left with y squared plus 3 halves y, and this is where I'm going to leave a little bit of a space, equals, and then when I add 2 plus 5 halves, so we have 2 plus 5 halves, gives me 4.5, and I'm going to put it into a fraction since everything else is a fraction, 9 halves. So now we are in the correct format. We have y squared plus 3y halves equals 9 halves. The variable is on one side of the equal sign, the number is on the other. So now comes the part where we deal with our magic number of 2 here. So the second term in our problem gets divided by 2. So when I divide 3 halves by 2, so 3 divided by 2, and I divide that by 2, I just get 0.75, which as a fraction is 3/4. So next what I have to do is I have to square this. So I will square my answer. Gives me this decimal. Again, I'll turn it back into a fraction, 9/16. And this will get added to both sides. So our trinomial is actually y squared plus 3 halves y plus 9/16 is 9 halves plus 9/16. Now we have this perfect square trinomial. I'm going to move it up here off to the side. This perfect square trinomial, meaning I actually have a binomial squared. And the binomial, again, is the first thing is the letter we have in our problem, which is y. And then the number I'm going to put is what we got when we divided by 2. So when we divided our middle term by 2, we got positive 3/4. So positive 3/4. So plus 3/4. Equals, and then I'm just going to do 9 halves plus 9/16. And we get 5.0625, which as a fraction is 81/16. So this looks a little bit neater than the line we had previously. Now, the next thing I want to do is I want to solve for y. So here we have something squared, meaning I need to get y by its lonesome. So first step is take the square root of both sides. So when I take the square root of both sides, the square root and the exponent of 2 will cancel out. It leaves me with y plus 3/4 equals. And then I will take the square root of 81/16. Gives me 2.25, which as a fraction is 9/4. And again, once I take the square root of a number, I get a positive and a negative value. So the last thing I will do is I will subtract 3/4 from both sides. So here in the problem we're adding. To move it over, I will subtract 3/4. 3/4 will cancel out, leaving me with y equals a positive and a negative 9/4 minus 3/4. So this is where we can actually do the math that we have in the problem. Both are fractions. I'm adding and subtracting. They both have the same denominator, so it's going to be easy to do it. So adding and subtracting fractions, as long as the denominator is the same, I just add and subtract the top. So one answer is going to be 9/4 minus 3/4, and the other is going to be negative 9/4 minus 3/4. So 9/4 minus 3/4 is going to be 6/4, which if we plug it into the calculator, 9/4 minus 3/4 gives me 1.5, which as a fraction is going to be 3/2. So y equals 3/2. So there is one value. And then the other one, we'll do negative 9/4 minus 3/4. Gives me negative 3. And there's the other value for this particular problem. So this one was much more involved due to the fact that we had fractions involved here. It was not nice and quick and easy. Now number 3 is a little bit different. We have 1/2 r squared minus 6r equals 2. So in terms of the setup where r's are on one side, numbers on the other, we're good. The issue we have here is the fact that I don't have just r squared. So here we are multiplying times 1/2, so we need to divide everything by 1/2. So when we divide everything by 1/2, 1/2 divided by 1/2 goes away. It leaves us with r squared. And then we divide negative 6 divided by 1/2. Gives me minus 12. And then 2 divided by 1/2 gives me 4. So notice I left a little bit of space here. So r squared minus 12r equals 4. So now we're in the proper format. R squared is by itself. R's are on one side of the equal sign. 4 is on the other. We're good there. So now comes the work that we have to do with that magic number 2 here. So take the second term and divide by 2. So negative 12 divided by 2 gives me negative 6. And then I have to square it. And that is going to give me $36. Notice I put the negative 6 in parentheses in the calculator. The reason being is if I did not do that, the calculator would read it as the negative value of 6 squared. If you want to square a negative number, you have to put the number in parentheses. So 36 here is going to get added to both sides. So we end up with r squared minus 12r plus 36 gives me 4 plus 36. So now what we have on the left-hand side here is a perfect square trinomial, meaning we have a binomial squared. And the binomial, again, whatever letter we're dealing with in the problem comes first, so r. And then the number we got when we cut in half is going to be the number. So we found it to be negative 6. And then 4 plus 36 gives me 40. The next thing I'm going to do is take the square root of both numbers. So we have, what that does is it will cancel out the square root and the square, leaving me with r minus 6 equals square root of 40. And whenever I take the square root of a number, we end up with a positive and a negative value, so plus and minus root 40. And we're going to add 6 here. So we get r equals 6 plus and minus root 40. and that is using completing the square in all possible scenarios and figuring out the values of r, x, y, whatever variable we have to use. Again, this is a more involved process. It is not as neat as the quadratic formula, but as it is with the quadratic formula, it will always work.